Hi, welcome to Infineta's webinar. My name is John O, and I'm the VP of Marketing at Infineta. Infineta Systems is a pioneer and leading provider of hyperscale WAN optimization products. These products help customers of all sizes and in all industries accelerate inter-data center WAN traffic. Our data mobility switch is the first and only solution that can significantly improve multi-gigabit WAN traffic. I encourage all of you to send in your questions throughout the webinar by using the comments box in the top right corner of your screen. At the end of the presentation, we'll answer as many questions as we can, or at least as much as time allows. Now, let me turn over the mic to today's presenter, Hasib Badani, our VP of Products. Hasib?
Thanks, John. Hi, everyone, and thank you for tuning in. This presentation is roughly divided into three sections. First, I'll spend a few moments laying out the problem set that the DMS addresses, the types of applications that the DMS is designed to accelerate, and how these applications are different from the classic user access and productivity applications that traditional WAN optimization solutions have been addressing. Next, I'll talk about the DMS, some of its key features, share some deployment types, and also share a comparative use case. And finally, we'll wrap up, and John will pick some of your questions for us to address live, and I'll try my best to address them properly. So let's begin. WAN optimization as an industry started out by solving the branch WAN, or what we call the north-south problem. Users were trying to access content sitting in a remote data center over a low throughput link. Many companies have been successfully solving this problem for some time. In fact, some of my colleagues here in Infineta and I come from WAN optimization or app delivery companies, so we are definitely very familiar with that space. The WAN optimization industry didn't really focus on the WAN interconnects between data centers because, frankly, the branch problem was a very lucrative problem for them to solve, and continues to be so. But with customers continuing to ask for a way to improve performance on the inter-data center WANs, what we call the hyperscale WAN, WAN op vendors have started to focus on that problem as well. But about the only thing that is similar between the branch WAN and the hyperscale WAN is really the word WAN, because the size and scale of these two and the applications that typically run on them are quite different. And consider an enterprise data center, serving 250 branches. If the link back data center from each branch is, say, an E1, you need no more than half a gig of bandwidth in the data center. Now, if you just think about an interconnect between two data centers for that same enterprise, typically 1 gigabit per second is the low bar when people talk about interconnects between data centers. So definitely the scale at which bandwidth, as in terms of gigabits per second, is used up between data centers versus for the branches, the scale is markedly different. We here at Infineta only focus on the hyperscale WAN problem. All our energies are focused on solving this pervasive yet unaddressed problem set. So in our conversations with customers, we're learning a lot about the traffic mix on hyperscale WANs, and it's definitely getting more and more complex in terms of how many different kinds of things are going on the hyperscale WANs. It used to be that these links were used for periodic backups, but more and more customers are telling us that the rate at which their critical data is growing is forcing them to continually grow the amount of data they replicate or backup to remote locations. In many cases, certainly data protection is the biggest driver for all the bandwidth between data centers. Virtualization, though, is also driving traffic on these WANs. We are seeing scenarios where customers push VMDKs across the WAN for DR purposes. Also, we are beginning to see customers use vMotion and other live migration solutions across the WAN, and that too is leading to requirements for more hyperscale WAN bandwidth. Another use case which, frankly, we never even considered 2 years ago is big data. We have had customers talk to us about moving large Hadoop data sets across the WAN, and they are complaining about the WAN latency impacting these transfer rates, which is making them rethink, in some cases, how they use the WANs for big data. So with some understanding of the application mix that is traversing hyperscale WANs, the next question from a product perspective is, how is this traffic different from the branch traffic for which some excellent tools exist in the market today to accelerate? So in looking at the branched WAN, what one sees is there's more user-to-machine traffic. This is a user sitting at some computer trying to access email, file access, or some ERP or some SharePoint app over a low-capacity, high-latency link. There could be tens of thousands of these connections, TCP flows, on that WAN, but each of these connections tend to be very small. They would be, in the hundreds of kilobits or megabits. They're steady, low-speed connections. But when you compare this to the hyperscale WAN, where one tends to see more machine-to-machine traffic, this could be replication, remote backup, live migrations. These are arrays talking to arrays, clusters talking to clusters. The profile is very different. Each of these connections or flows may scale all the way up to a gigabit per second. So there are fewer flows, but each one of them is bursty, it's higher speed, it's very aggressive, and in some cases they are very latency sensitive. So clearly the problem set for the hyperscale WAN is markedly different from the branch WAN scenario. And the product that we have built here at Infineta, the data mobility switch, is focused on this hyperscale WAN problem. The DMS, and that's the picture of the appliance on the screen there, was designed to specifically address the highly aggressive, latency-sensitive traffic traversing hyperscale WANs. The DMS can accelerate traffic at up to 10 gigabit ingress speeds and can do so while incurring extremely low port-to-port latencies. We are seeing port-to-port latencies in the tens of microseconds on the DMS. And let me call out, this is not milliseconds, it's microseconds is the latency measured on the DMS. And typically the latency band is anywhere between 32 microseconds to right under 100 microseconds in the absolute worst case. So even with all the processing that the DMS is carrying out at 10 gigabit rates with the low latencies, the DMS still continues to deliver 80+% reduction ratios on all inter-data center. This high reduction ratio is a testament to the unique hardware-based approach that we have taken with the DMS. You can run this product at 1 gig or 10 gig. The reduction ratio for a given data set will be exactly the same in all scenarios. Finally, given the fact that the DMS is an order of magnitude faster than most of the WAN optimization solutions in the market, it delivers a 5 to 8 times price performance advantage over all the competition. So let me talk about the feature set that the DMS carries. There are basically 3 legs to this product: control, optimize, and reduce. We call this our core feature set, COR. Control entails identifying the traffic that the customer would like us to accelerate, prioritizing it on business policies, and ensuring minimum performance guarantees for select traffic in the network. The optimized feature set allows us to accelerate a single flow to 1 gigabit plus rates. Given the unique congestion control algorithms that we have defined and implemented in our system, the system can effectively fill a 10 gig link with only 10 flows at any distance. This is remarkable. Nothing in this business is able to scale this well. No other product even comes close. Our reduction portfolio consists of 3 engines: repeat byte suppression, deduplication, and compression. All of these are implemented in hardware and are guaranteed to not falter when the speeds go up. So let me walk through each one of these for you. So let's talk about repeat byte suppression first. So in a lot of the hyperscale WAN traffic that we have analyzed over the last 2 years, we noticed that a lot of bytes repeat over and over. So these could be nulls, spaces, what have you. The RBS engine suppresses all repeating bytes in hardware at line rates and simply passes along a reference for the repeating bytes to the next engine. And the next engine in the path is deduplication, what we call the velocity dedupe engine. The velocity dedupe engine is the company's crown jewel and is able to dedupe WAN traffic at 10 gigabit per second rates at very, very low latencies. And I'll talk about it more on the next slide. Finally, before packets leave the system, we opportunistically compress them using standard base compression to get some more reduction oomph out of the data. So the Velocity dedupe engine, like I said before, is the company's crown jewel. This is an industry first. No other dedupe implementation has ever been carried out in hardware. This is the first one, and we implemented the entire thing in programmable logic, actually. And that's not all. The dedupe algorithm that we used, they're not based on the classic fingerprinting or chunking approaches that others have taken. We have 5 patents filed for our dedupe algorithm, which is, like I said, is implemented in programmable logic. The Velocity dedupe engine, given its design, is able to run at 10 gigabit speeds and incurs extremely low, typically in the tens of microseconds of process latency. The fundamental design principle here is parallelism. We can achieve higher speeds because we are processing received data in parallel and can look up input data across a very large dictionary at incredible speeds. The result is a system that can dedupe traffic at 10 gigabits per second speeds and produce sustained and high reduction ratios. Here's an example of the DMS in action. The test here was to accelerate high-speed replication. The customer ran this test on an uncapped WAN, and the WAN happened to be a 10 gig link, to see how well our system can reduce their traffic. So let me call out the 3 graphs on the screen. The first graph on the screen captures reduction performance over time, and each one of these graphs has a 1-hour time window. The second graph shows the LAN side ingress speeds for the replication traffic. And the third graph shows the WAN traffic, i.e. the traffic that is leaving our system and going towards the WAN. So let's follow the progress here. The test started with the replication traffic running at a little over 9 gigabits per second. And notice that it scaled up pretty quickly. So it's very fairly aggressive traffic. Initially, there was no real reduction being produced, and that's okay because the system is learning about all the blocks being replicated across the WAN. After a short while, though, once the DMS's dictionary has been seeded, reduction scaled up to the high 80% range. Most importantly, notice that even when the reduction is low, the input was the same as when the reduction was high. This is the magic of having a purpose-built system. Regardless of the input speed, regardless of the reduction ratio, the application never needed to slow down. And that's the incredible part. So another advantage of having a scalable hardware-based approach is deployment flexibility. So as you can see on the screen, this is our inline deployment example, one of them. Now our systems have enough horsepower to be deployed inline in data centers without any concern that the DMS will become the bottleneck in the network. Even in the face of sustained bursts, the DMS can easily identify the traffic it is supposed to accelerate and let the rest through without touching it. I mean, traditional WAN optimization products are forced to sit out of path and typically need some sort of load balancing to make things work. In our case, there's no such requirement. We can sit in line and we do not require a router or some sort of an interception device to send traffic to us. Even in environments where routing asymmetries may occur, the DMS can be deployed such that 2 setups can talk to each other over dedicated inter-switch ports and exchange flow-specific information, and they will make sure that nothing breaks in your network just because of a route flag. Of course, if customers really want to deploy out of path, they can do that too. In fact, we have a really unique out-of-path deployment option where even routing symmetries have been addressed and thought through. And we can get into details of each one of these, by the way, if you like, in one-on-one conversations. Please feel free to reach out to us. But in all this talk about deployments, let me actually pick an example of a real use case where deployments and actually load balancing in particular came up. So the diagram that you see on the screen is from a real use case. This customer has 2 data centers with 2 OC48s connecting the 2 data centers, and they are running replication traffic, and they're running into replication from that's the bottleneck. The customer worked with the storage vendor and calculated that in order to meet their RPO goals, they would need to basically run at 7 gigabit per second on average. So push 7 gigabit on a 5 gig WAN, which is really not that big of a deal. That's not a stretch. So they talked to a number of WAN optimization vendors, and one of the proposals they received was basically as follows. It said, you need 14 of the largest WAN opt boxes from this vendor, per site, and that the customer must upgrade their routers so that they can use the routers for load balancing, because the existing routers did not have enough horsepower to do so. So essentially the customer was asked to buy 28 units for the 2 sites and upgrade the routers. So I don't know what the total proposed dollar figure was, but the customer basically told the vendor, you're crazy, we're not going to do that, we're not going to make this large investment, and they walked away. So compare this. So let's keep this in mind and look at the next slide where I kind of show how our deployment worked in the same scenario. So our deployment was very simple. Single inline DMS, no change to the current network. Yeah, simple, very, very simple. So let's think about this, right? So of course with us, you just need a single DMS. So the proposal overall is a lot less expensive. It's just 1 box versus 14 boxes per site, which is great. But what's more important sometimes is the operational simplicity that the DMS brings in, which makes it a lot more attractive to not just the application guys who really just want to solve their problem, but the network or storage operations guys who have to manage this new equipment on an ongoing basis. And let's not even mention the real estate and power requirements that the other solution would have required with the 28 boxes and their upgraded routers. So that being said, let me just call out some of the things we talked about today. The capability switch. It has been designed to accelerate highly aggressive workflows. That's the goal. Any workflows running over the hyperscale WAN is what the DMS can accelerate and accelerate very well at very high speeds. The reduction ratios that the DMS delivers are the highest at the highest ingress speeds. Regardless of speed, you will get the best reduction ratios with this product. The DMS is the most scalable appliance compared to any other WAN acceleration products out there. It has the simplest deployment and management for the data center environment. The port-to-port latencies for the DMS are the lowest in this industry. Nothing comes close. And more importantly, in some cases, this is the most competitively priced product. Per gigabit, $1 per gigabit, this is the best product out there. So with that, I'm going to turn it over to John, who's identified some questions that he'd like me to address before we close for today. John?
Thanks, Hasib. Looks like we have quite a few questions here, so let's try to cover half a dozen and then wrap it all up. So question number 1. We noticed that there's a lot of EMC mentioned on your website. Do you improve all replication jobs, or is it mostly just EMC stuff?
Great question. So yes, we talked about EMC a lot, but we accelerate all replication traffic. In fact, we find that our product seems to work very, very well for SnapMirror traffic as another example as well. And not just replication traffic. We have trials going on in some cases. Customers are trying Hadoop traffic, customers doing VMDK backups, large file transfers, and so on. So this is really a very flexible product. It's a very versatile product for inter-data center WAN traffic.
Great. Question 2. I think big data processing was more for the Facebooks and Twitters of the world. What would a normal enterprise type of customer use you for in terms of big data?
So 2 years ago, if somebody asked me the question, will you ever see Hadoop traffic or any such thing on the WAN, and will you accelerate that? I would have probably said no. But now that we have seen pull from customers who are running into cluster-to-cluster log transfer issues or Hadoop issues or Cassandra issues, definitely there is a use case for Hadoop in the enterprise. We have one deployment right now where the customer was running into latency issues over a 10 gig LAN, and they couldn't finish a 4 to 5 terabyte transfer in a 24-hour window. So certainly more and more we are seeing enterprises use all these scatter-gather type applications to solve some of the problems that they have today.
Thanks, Hasib. Next question. Private circuits come in all sizes. What's your target circuit size for this DMS or data mobility switch?
Okay, so really the target size, I guess, anything from an OC12 to an OC192 is fine. The customer could be running at any speeds. I guess another way to think about this is, let's say you have an OC12 today, and instead of upgrading, you'd like for us to make it look like an OC48. We can do that, so you don't need to upgrade. Or if you have an OC48 today and you want us to make it look like an OC192, we can do that too. So that's another way to think about it, and I guess that changes the question as well.
Great. Next question. Does your product work just in a one-to-one situation, or does it also get used in a many-to-many data center topology?
So the product has been designed for a mesh deployment, so it can be in a many-to-many topology. For replication in particular, we typically see 3 to 4 sites talking to each other. Typically it's 3. But in other scenarios, such as in cluster-to-cluster scenarios, definitely there could be many sites talking to each other, and definitely the box can support those kinds of deployments as well.
Great. The next question is actually something that customers ask a lot, and Hasib, you've answered this quite well in the past. So the question is, there are ways to tune TCP quite easily. What does your TCP feature do that's any different from that? Okay,
it's a fun topic. So there are many ways to solve this TCP problem. So there are a lot of companies and a lot of universities have spent a lot of time looking at it. There's high-speed TCP, big TCP, many flavors of these Vegas or Reno variants out there. Typically the problem that they're trying to solve is of a long-lived connection that is trying to go over long distances and is trying to reach very high speeds. So in a contained environment, these things work very well. However, when you look at a hyperscale WAN and the kinds of traffic that is running on it, what you see is not all connections are equal. So some runs faster in terms of megabits per second or gigabits per second, and some run slower, and they start and stop. Particularly with replication, the way traffic works is if there is data to replicate, you're going to see a burst of data. But then for some time, you will see nothing. And then it'll start again, then stop again, and so on. So when you have these stops, what happens to my WAN bandwidth? I mean, is it underutilized or what? Typically, with TCP optimized for endpoints, what happens is it takes time for even the most aggressive TCP to ramp up and start using or utilizing all the WAN bandwidth. And that is lost money because somebody's paying for that bandwidth. The way we have designed our congestion control algorithm is definitely it's very aggressive on the WAN as it should be. But even on the LAN side, the way we redistribute bandwidth across equally fast running connections or make sure that the more aggressive connections get as much bandwidth as needed without wasting bandwidth, it's very unique. And we really feel that the way we have designed our TCP implementation is the right way to do it because with our solution, as customers have seen already, the WAN is utilized to the level that you would like it to be all the time. There is there's no gap, there's no loss of bandwidth usage. Hope that answers the question.
Great. So the last question, Hasib, is what are the application protocols you specifically support or optimize?
So the system has been designed to accelerate all traffic running on hyperscale WANs. They could be TCP-based, UDP-based, doesn't matter. It will look at all traffic, it will accelerate all traffic, and it will reduce all traffic.